Okay, so here are my worked solutions for the November 22 maths paper 1. It's non-calculator. Put at the top just a reminder of the grade boundaries that you need to be mindful of when you're looking at what what you're working through. So over the two papers you would need a combined mark of 106 to get an A star, 80 to get an A, 52 to get a B, 26 to get a C, out of a total of 160 marks. In brackets underneath, just to give you a sense of on each paper, 53 on each paper would get you an A star, 40 would get you an A, 26 would get you a B, and you need to get at least 13 marks to avoid a U. Now I've ticked on the front the questions that we can answer based on the teaching that I've done with you this year. So on the paper we can access 44 of the marks, which if you could get them all right would get you in that A zone, which would be superb. And that's what we will focus on in this solution set. Okay, so the first page aren't questions, they are formulas that you may find helpful. For the work that we've done, the area of a trapezium could be useful, the volume of a prism could be useful. We haven't done anything with spheres or cones. We haven't done any triangle work other than right-angled triangles, which is in this information. But the other one on here, which is one you'll certainly need to use in paper 2, not today, is the quadratic equation formula. Okay, question 1, Venn diagrams. In a group of 200 people, 105 do not have black hair and do not wear glasses. 20 have black hair and wear glasses, and 70 people have black hair. Complete the Venn diagram below to show this information. The universal set E contains all 200 people. So that's saying that we need to have numbers written within that rectangle which will add up to give 200. Okay, so we know that 20 people have black hair and wear glasses. So that's the one that gives us the overlap. There's 20 people in there that have black hair and wear glasses. 105 do not have black hair and do not wear glasses. So those are going to be the ones that aren't in any of those circles. So that would be outside. And if I know 70 people have black hair, that means that the full black hair circle has to add up to 70, which means that must be 50. So there's one little region that we don't yet know, which is this one here. And we know that all of those numbers have to add up to 200, and that at the moment adds up to 175, which means that must be 25 in order to add up to 200. So there's 3 marks for that. There'll be 3 marks if you get them all, 2 marks if you only get one of them wrong, 1 mark if you get 2 of them wrong, no marks if you get them all wrong. One of these people is chosen at random. What is the probability that this person wears glasses? So for a probability, it's a fraction. The number in the denominator, the bottom of the fraction, is what the total possible number of outcomes could be, which in this case is 200. And the number of people wearing glasses is the 20 that wear glasses and have black hair, and those that only wear glasses. So you're looking at 45 out of 200. There'll be 1 mark there for the correct answer on top of the fraction, and 1 mark for the correct answer at the bottom of the fraction. Okay, question 2, constructions. Triangle ABC is shown in the diagram below. Using only a ruler and a pair of compasses, construct an accurate drawing of the triangle ABC. Side AC has been drawn for you. All construction lines and arcs must be shown. So I'm going to quickly go through this, and when I upload it I'll include a link to the practice work that we did on this back when we were getting ready for the numeracy exam. To draw a 60-degree, to construct a 60-degree angle, it's the most basic of all you need to do is put your compass point where you want the angle to be formed, open it, doesn't have to be any particular distance, and mark part of the circle like that. Then you put the compass point where the arc has crossed the original line, and you make it cross over the arc you'd already drawn. Joining from A through that then gives you a 60-degree angle. So that there is going to be 60 degrees. What the examiner is looking for is the pencil bits as well. I've just drawn that up the page because it doesn't tell me how long AB is. So I've now got to come here and do BC, which is 45. Now the 45-degree angle is a bit trickier because in order to draw the angle there, the first thing we have to do is draw a 90-degree angle and then cut it in half. So the way that I showed you to draw a 90-degree angle was to extend the line from C, put the compass point at C, and cross that side of it and that side of it. Then you need to put the compass point there. You now have to open it wider than the distance AC, otherwise the arcs don't cross. So we're going to do that there, like that, and then move the compass point to the other side. This isn't great when you're left-handed, and draw the second arc. So what you've got there then is a 90-degree angle. We don't want a 90, we need to cut that in half. So to bisect an angle, if I just show you over here, just to remind you, if I wanted a 30-degree angle, once I've finished that, I then put my compass point there. It doesn't matter if it's changed distance, and mark it out there, mark it out there, where they cross would cut that in half. So it's the same job here. First of all, mark on the 90 side, then mark on the original line, move the compass point to where it crosses there, and then move the compass point to where it crosses. Oops, that's a mess. Compass point to where it crosses here, and then join the line through C to that. And that then is 45 degrees. So the 45 is the more complicated of the two to do there. You'd have one mark for the 60-degree angle, there'd be one mark for the 90, and then the final mark would be for bisecting the 90 to get the 45. So as I said, I'll hyperlink you to the work that we did on that back in the autumn. Question 3. Express 1575 as a product of its prime factors in index form. So we need to repeatedly divide that number by prime numbers until we end up with 1. It ends in a 5, so I know 5 will go into it. 5 goes into 1, doesn't. So we do 5 into 15, 3. 5 into 7, once, remainder 2. 5 into 25, 5 times. That also ends in 5. So 5 into 3 doesn't go. 5 into 31 goes 6 times. Remainder 1. 5 into 15, 3. Okay, 7 goes into 63 9 times. 3 goes into 9 3 times, and 3 goes into 3 once. So we keep dividing until we end up with 1. Okay, so out of the 3 marks, that's my method mark. I have used an appropriate method to break that down into prime factors. In order to get the second mark, you'd want to say 1575 is the same as 3 times 3 times 7 times 5 times 5. That wouldn't get you full marks because it's instructing you to give it in index form in terms of its powers, which would be 3 squared times 7 times 5 squared. Now, I would put a 1 in there. It doesn't matter in this question, but if there was a part B, and there often is, which asked you to explain how you know 1575 isn't a square number, it isn't a square number because if it was a square number, each of those powers would be an even digit. That's not even, it's odd, so it's not a square number. You could be asked, what's the smallest number you could multiply this by to make it a square number? And the answer would be 7, because then you'd have 3 squared, 7 squared, 5 squared. But you wouldn't lose that last mark if you just had the times 7. And if you just went straight from that to that, missing out that, you'd get the 2 A marks. Question 4. Simplify the following expressions. Okay, so this is an indice question. 2 times 3, I can just work that out, is 6. And then the P terms, so when you're multiplying bases are the same, so P and P, you add the powers. So that would be 3 plus 4. And then Q, there's actually a little 1 above that, going back to what I was saying up there, so it's not 0. So it would be Q to the 1 plus 7. So the answer is 6p to the 7 q to the power of 8. Okay, so there's 1 mark for getting the p right, 1 mark for getting the q right. Okay, so we're going to expand the brackets and simplify. This one, you multiply whatever's outside by every term that's in, so it would be 7a times a, 7a squared. 7a times 5 will be 35a. That's plus, signs are the same, answer's positive. Then we're on to the second bracket, so I've got 2 times 3, 6a squared, minus times a plus, signs are different, answer's negative. 2 times 6, 12a, minus times a plus, negative. 2 times 7, 14, minus times a minus is a plus. Signs are the same, the answer is positive. Then we can tidy that up. I got a 7a squared, take away 6a squared, is 1a squared or just a squared, it doesn't matter. 35a take away 12a is 23a, and it's plus 23a. Remember, once we finish getting rid of the brackets, we've done all the multiplying. That's the end of the minus makes a plus rule. Here we're at 35 plus 35 on the number line, and we're taking 12 off. We're going down 12 places, and then plus 14 is the only only term. So for that, there will be a method mark for expanding the brackets. There'll be a B mark for correctly expanding the first bracket, a B mark for correctly expanding the second bracket, and a B mark for simplifying it, for tidying it up. Right, question 5. This is equation of a line. Which I haven't covered with you. If you think you have covered that in the past, or you want to practice that with a tutor, then by all means do so. Question 6, similarly, I haven't covered this. This is dimensions of formula, which you may have done with Miss Rook last year if you want to look back at that. Question 7, standard form, we've done. Calculate the value of 3 times 10 to the power of 4 divided by 6 times 10 to the power of 3. So when we're multiplying or dividing numbers in standard form, it's easiest to do it by keeping in standard form. When we're adding or subtracting, like we're going to be doing in part B, it's easier to turn it into full numbers, do the sum, and then turn it back. So what we're going to do this is 3 divided by 6 times 10 to the 4 divided by 10 to the minus 3. 3 divided by 6 is 0.5. And then when you divide, back to indices again, when you divide bases that are the same, you can subtract their powers. Now be careful here, because you're subtracting a negative number. So that becomes a plus. So we've got 0.5 times 10 to the power of 7. The question instructs us to give our answer in standard form, and that's not in standard form, because a standard form number has the first part, which is always a number between 1 and 10. So I'd now write that in standard form, and just to go back to when we were practicing standard form, I would keep making you think of the place value of the columns. The first column, units, will be 10 to the 0, tens 10 to the 1, hundreds 10 squared, etc., etc. And on this side of the decimal point, those powers would be negative. So 0.5 would be 5 times 10 to the negative 1. So that there is 5 times 10 to the minus 1 times 10 to the 7. So the final stage, the number part is going to be 5, and then here I'm going to add those because I'm multiplying same bases. So minus 1 add 7 is 6. So there's 2 marks there. There'd be 1 mark if you got it down to 0.5 times 10 to the 7, and then 1 mark if you then correctly put that back into standard form. So as I mentioned, for part B, when I'm adding, I'm going to turn these back into normal numbers. The way that I would do that, lots of space, so I would put my columns in, 10 to the 1, 10 to the 2, 10 to the 3, 10 to the 4, let's go up to 10 to the 5. So that's my place value. So 4.78 times 10 to the 4. The 4 is going to go into the 10 to the 4 column, and then 7, 8. And then to keep them in their place, I've got to add those 2 zeros to keep it away from the decimal point. And then 1.5 times 10 squared. The 1, the most significant digit, will be in 10 squared, 5, 0. Do your addition. 0, 5, 9, 7, 4. And then we need to write that in standard form, which will be 4.795 times 10 to the 4. One mark if you left it as 47,950. 1 mark if you did as instructed and wrote it in standard form. Question 8. Which complete method using Pythagoras' theorem can be used to find x? Okay, so with Pythagoras' theorem, you need to square the sides. Then you need to decide whether you're going to add them or subtract them. The decision is based on whether you're trying to find the longest side, which is the hypotenuse, which is pointed at by the box. So that's the longest side. If I'm trying to find that, I need to add my squares together so I get a bigger number. If I am trying trying to find one of the shorter sides, it means I need a smaller number, so I'm going to subtract them. So x would be 25 squared minus 10 squared. Except it's not x at that point, it's x squared. It's the sum of the squares. So x squared would be that squared, take away that squared. Then to get the x back to the x, you've got to do the opposite of squaring, which is square rooting. So the one I'm looking for is that, which is there. So as I've said in many other videos, if you've got a past paper a question where they're giving you a multiple choice, that doesn't mean you're not allowed to do the work for it. Part B, which of the following calculations can be used to find y? So this time, right angle triangle, it's a Pythagoras trig question, almost certainly. But this time I'm given an angle, which means if I'm working with an angle, it's going to be trig. With trig, you name your sides. Opposite is the side you're trying to find in this case, which is opposite the given angle. Hypotenuse is the one you're always trying, is always pointed at by the right angle, and the one that's left is the adjacent. So then you've got to remember your triangles to identify which one it's going to be. Now I want to find y, so it's the opposite, so I need to have the opposite in it, and I need to also have the one that I know, which is the hypotenuse. So that's the one I'm going to use. I want to find y, so sine of the angle is opposite over hypotenuse. Which is going to be y over 25. So sine of the angle is opposite of the hypotenuse. Sine of 40 is y over 25, which is that one. 1 mark for each. Next one is circle theorems, which we run out of time and weren't able to practice, but you might have notes from year 10 on that. Question 10 is inequalities, and this is the OCW question, so how you lay it out is going to allow you to gain those additional 2 marks. On Monday morning, Tom picked n apples from a tree. Kerry picked 5 times as many as Tom. Monday afternoon, Tom picked 19 more apples. Kerry gave 7 of her apples to Tom. Kerry still had more apples than Tom. Write down an inequality in terms of n to show the above information. Use your inequality to find the least possible number of apples Tom picked on Monday morning. You must show all your working. So Monday, what do we know about Monday? Tom picks n apples. Kerry picks 5 times as many. Now you need to decide whether 5 times is 5n or 5 plus n or n plus 5. If it's times as many, times to you means multiply, yeah? And that's correct. But if you're not sure, change the n to 10. Tom picked 10 apples. Kerry picked 5 times as many. So 5 times 10 is 50. It's not 15. So that's going to be 5n. On Monday afternoon, Tom picked 19 more apples. So in the afternoon, he started with n, or 10. He picked 19 more. So 10 add 19 will tell you how many he's got next. So that would be n plus 19. And then Kerry gave 7 of her apples to Tom. So he gets another 7, but that means Kerry's 5n is now 7 apples fewer. So Tom picked 19 of his own and Kerry gave him 7. Kerry had 50, but has given 7 of them to Tom. So tum there is n plus 26. Kerry still has more apples than tum. Write down an inequality in terms of n to show the above information. So Kerry has that many, tum has that many, and Kerry still has more, so that quantity is bigger than that quantity. So we need to put an inequalities in there, and the inequality points at the smallest amount. So there's your inequality. Now we need to use it. So we treat it now just like solving an equation. I need to add 7 to that, which means I add 7 to that because I'm trying to get the ends on their own. That means on this side I'm left with 5n. On this side I've still got that n there, and I've now got 33. Now I want to take that n off there, which means I've got to take an n off there. So I've now got 4n is greater than 33. Now I divide by 4, which means I have to divide that side by 4. So n must be greater than 33 divided by 4. Now 33 divided by 4 is going to be, so 4 eighths are 32, and then we're going to have a remainder of 1, or we're going to have a decimal, and so on. So it's going to be, let's go decimal, 1, 4.2, etc, etc, etc. N has got to be bigger, it's got to be a whole number because we're talking about apples, and it's got to be bigger than 4.2. So the least possible number of apples that Tim has got to pick is 5. So n is at least 5 apples. Can't be 4 because n is going to be greater than 4.2. Okay, so 6 marks there. So the 4 marks will be M1, A1, so the method of forming them and then getting that 5n minus 7 must be bigger than n plus 26. Then you're going to have an M1, sorry, an A1 for getting n is greater than 33 over 4, and then an A1 for interpreting that means it's got to be at least 5 apples. And then the OCW is just for this consistency in how you lay it out. So tum is that, carries that, tum is that, carries that. Then we're into the algebra, then I have a conclusion. So plus 2 for me, OCW. Question 11 we haven't done, that's proportion. Question 12, transformations. So this is now in the second half of a higher tier paper. That means that it's going to be the only transformation that's only for the higher tier, which is the the negative enlargement. So I almost know that before I start it. It's worth 3 marks. I'm moving A to become B. So 1 mark for saying it's an enlargement. This side here becomes that side there. So it's increasing, it's getting bigger. 2 squares become 4 squares. So scale factor 2, but it's also been flipped, which means it's a negative scale factor. So that's 1 mark. That's 1 mark. And then for the final mark, you need to say where the center of enlargement is. So center, and to find that, you join up your corresponding sides. So that point there is going to correspond with that point there. this corner here is going to correspond with that corner there. And this bit here, you don't need to do 3, I can already see where it joins, but just to be on the safe side, you can see it just extends that line there anyway. So that is your centre of enlargement there, which has got the coordinate -3, 1. So that's, you're almost going to be looking for that. It's going to come up on one of the papers, can't remember which, the negative enlargement. Question 13, congruent triangles, haven't done. Question 14, inequalities on a graph, haven't done. Question 15, recurring decimals, we have. So we let x equal 0.6, and then the 545454 carries on infinitely. We want to get it so that the same repeated part is the only parts to the right of the decimal point. So I can do that by multiplying by 10 and getting 10x equals 6.545454 and so on. Now if I subtract those, my decimal side isn't going to cancel each other out because the numbers in the columns aren't the same. So I need to multiply again to get a second set of a second number where the repeated digits are all 545454. If I multiplied it by 100, I'd end up with 65.45454. So that won't help. So in this case, it's one where we have to multiply by 1,000. And when we multiply by 1,000, the decimal point ends up there. So we get 654.545454. Now when I subtract these two, all those decimals are going to cancel. So I get 1000x minus 10x. And on this side, 654 minus 6 will be 648. Then to write it as a fraction, we're going to divide both sides by 990. So 1 mark for correctly multiplying by 2 powers to align the decimal points, the decimal parts, and then 1 for doing the subtraction and ending up with the right answer. Okay, 15b. So we need to work out what this is. Laws of indices. The number on top of the fraction tells us that it's a power, it's squared. The number on the bottom of the fraction tells me it's a root, and the minus tells me it's the reciprocal, which means you turn the fraction upside down or it's 1 over. So 27, it means I'm going to have the cubed root. No, it doesn't. It means I'm going to have 1 over the cubed root of 27 squared. So reciprocal, 1 over. Root, cubed root of 27, and then that's all squared. Now there's a limited number of cubed numbers they expect you to know. You've got 1 times 1 times 1, which is 1. 2 times 2 times 2, 2 2s are 4, 4 2s are 8. 3 times 3 times 3, 3 3s are 9, 9 3s are 27. So the cubed root of 27 is 3. So this then becomes 1 over 3 squared, because the cube root of 27 is 3. And 3 squared is 3 times 3, which is 9. So it's negative, so it's 1 over. It's got a fraction, so there's a root. It's a power, so it's whatever the power is. So the final answer is 1 over 9. You get 1 mark if you manage to put it all into that form, and then 1 mark if you manage to turn it into a ninth. Question 16, cones and cylinders, haven't done. Question 17. So this is surd. Evaluate the mean of the following 3 numbers. So we know that to work out the mean I have to add them together and divide by 3 because there are 3 numbers. I can't add them together until they're all in the same format. So this is where we have to simplify the surd. And it's using this bit of knowledge that is in your surd notes. The square root of a times b is the same as the square root of a times the square root of b. So if I can write 20 as a pair of a factor pair where one of the numbers is a square number, 4, then I can then write that as the square root of 4 times the square root of 5. The square root of 4 is 2, so that's 2 root 5. So now I can add 11 root 5 and 2 root 5. I've just got to deal with this. Root 5 cubed is root 5 times root 5 times root 5. When you multiply a square root by another square root of the same thing, then that just becomes the square root of 25, which is 5. So that is in fact the same as 5 root 5. So I can now add, so the total will be root 20 plus 5 root 5 plus 11 root 5. So that's going to be 11, 16, 18 root 5. Mean will be 18 root 5 divided by 3. 3 goes into itself once and into 18 6 times. So that's 6 root 5. So 3 marks for that. 1 mark will be for writing root 20 as 2 root 5. 1 mark will be for writing that cubed as 5 root 5. 1 mark would be then working out what the mean is going to be. Question 18 we haven't done. Question 19 we haven't done. Question 20 we haven't done. And then finally question 21, we have done this, although in slightly different form. This is basically kiss and smile. But before that I need to get that together on the left hand side. To do that I would have to take it off that side, which means I have to take it off that side as well. So that can be written as that. Okay, take it off there, take it off there, that means that's a 0. Now we've got our kiss and smile, so it's that times that minus that times that all over that times that equals 0. Tidy up the top, that times that 4x squared minus 5x minus 2x, minus times a plus, minus 2 all over x plus 1 4x minus 5. Okay, so the top of that now, I got 4x squared minus 7x minus 5, take away another 2, minus 2 all over x plus 1 4x minus 5 minus 5 equals 0. On top we've got something we can factorize, and we practiced. So now we're going to factorize 4x squared minus 7x minus 2. If you remember that you multiply those two together, so we got minus 8, and I want to get a factor pair of minus 8, so 1, 8, 2, 4, 4, 2, so it's one of those that is going to add to minus 7. So So to make minus 7, I need plus 1 and minus 8. So you then rewrite that, 4x squared plus 1x minus 8x minus 2. Deal with the first group. What can I take out? Just x. 4 plus 4x plus 1 is left inside. X times 4x, 4x squared, x times 1, 1x. Do the same with the second, but you know that in the bracket you need to have 4x plus 1. So I can see I can take 4 out of there, but if I do plus 4, sorry, not 4, 2. If it's plus 2, I can have plus 8x plus 2. So it's got to be minus to give me the same sign. 4x plus 1 then repeats, and x minus 2 then repeats. So the top of this becomes 4x plus 1 bracket x minus 2 all over x plus 1 4x minus 5 equals 0. Now if we just had that, we then want to know what value of x makes that one go to 0 and what value of x makes that one go to 0. The fact it's on top of the fraction makes no difference, because if the value of x is 2 would make that go to 0. If that goes to 0, the whole top goes to 0, because it'll be 0 times whatever that is. Anything times nothing is nothing. When you divide by 0 by anything, you just get nothing. So we do the same thing, and there's not much room here, and you have got more room. So we've got 4x plus 1, x minus 2 equals 0, all over x plus 1, 4x minus 5. So we just deal with the numbers on top. Either 4x plus 1 equals 0, take the 1 off, divide by 4. So minus a quarter is one answer, because that will make that become nothing. Or x minus 2 equals 0, which is x equals 2, which would make that 0, which would make that whole thing 0. So those are the two answers to that question. Now this is an A-star question, okay? So I accept that that's challenging, but it just comes from Kiss and Smile, which you were all really good at. The only difference is you did have to make that move to make it a Kiss and Smile by bringing that to the left-hand side of the equal sign. Okay, so that was November's paper 1.